Hello and welcome to my YouTube channel ChemWis. In this video we are going to learn mass spectrometry of aliphatic ethers. We will learn how this technique provides unique insights into their molecular weight, fragmentation pattern and structures. We will first go through basic fragmentation rules for aliphatic ethers. For that, let's have a hypothetical ether in which Rs is a smaller group and Rl is larger. In ether, the most loosely bound electrons are lone pair of electrons. Electronic bombardment removes one of those electrons and thus lead to the formation of radical cation called molecular ion. The first rule is regarding intensity of this molecular ion. The rule 1 states that molecular ion peak is stronger than those of isomeric alcohol. Rule 2 is regarding fragmentation of molecular ion. CC or CH bond next to oxygen generally breaks to generate fragment ion. The most prominent fragmentation is the one which expels the largest radical. Thus, in this molecule, removal of H radical will give alkylated ketone that will correspond to peak with M by Z value of M-1. Removal of a smaller R group as radical will give O-alkylated aldehyde with larger R group, while removal of larger group as radical will give O-alkylated aldehyde with a smaller R group. So, according to the second rule, the alkylated aldehyde with a smaller R group will be the most prominent as it is formed by the removal of largest group, and formation of protonated ketone corresponding to M-1 peak will be the least favored. Third rule is that the molecular ion can eliminate alkoxy radical to produce carbocation. Fourth rule, if O-alkyl group of the first fragment ion has beta H, then there is elimination of beta hydrogen to produce alkene and protonated aldehyde or protonated ketone. Let's have this hypothetical first fragment ion with beta hydrogen. The carbonyl group leaves at the same time. There is elimination of beta hydrogen and protonation of eliminated carbonyl compound to produce alkene and protonated aldehyde or protonated ketone. According to the fifth rule, ethers with delta hydrogen show M-alcohol peak due to loss of alcohol, M-alcohol minus alkene due to loss of alcohol and alkene, and M-alcohol minus alkyl due to loss of alcohol and alkyl group. For better understanding, let's have ether with delta hydrogen. Elimination of one non-bonding electron gives molecular ion. Delta hydrogen abstraction gives another radical cation. Elimination of alcohol molecule gives radical carbocation that corresponds to M-alcohol fragment. Elimination of alkene from this gives new radical cation that corresponds to M-alcohol minus alkene fragment. M-alcohol radical carbocation can eliminate alkyl radical like this to produce cyclobutyl carbocation that corresponds to M-alcohol minus alkyl fragment. Let's have few examples for more clarity. Mass spectrum of diethyl ether. Molecular weight of diethyl ether is 74. Removal of one non-bonding electron after electronic bombardment gives molecular ion with M by Z 74. It has proton at alpha carbon, so removal of H radical gives O-ethyl acetaldehyde oxonium ion with M by Z 73. The O-ethyl group has beta hydrogen, so it will undergo beta elimination to produce ethylene and protonated acetaldehyde with M by Z 45. The parent ion can undergo beta cleavage to produce methyl radical and O-ethyl formaldehyde oxonium ion with M by Z 59. It also has beta hydrogen, so beta elimination like this will give ethylene and protonated formaldehyde with M by Z 31. The parent ion undergoes alpha cleavage like this to produce ethoxy radical and ethyl carbocation with M by Z 29. Mass spectrum of diisopropyl ether. Molecular weight of diisopropyl ether is 102. Removal of one non-bonding electron after electronic bombardment gives molecular ion with M by Z 102. It has proton at alpha carbon, so removal of H radical gives O-isopropyl acetone oxonium ion with M by Z 101, which is not visible in the spectrum. The O-isopropyl group has beta hydrogen, so it will undergo beta elimination like this to produce propylene and protonated acetone with M by Z 59. The parent ion can undergo beta cleavage to produce methyl radical and O-isopropyl acetaldehyde oxonium ion with M by Z 87. It has beta hydrogen, so beta elimination like this will give propylene and protonated acetaldehyde with M by Z 45. The parent ion undergoes alpha cleavage like this to produce propoxy radical and isopropyl carbocation with M by Z 43. Mass spectrum of 1-methoxyhexane. Here I will explain the formation of fragments with the given M by Z values. Molecular weight of 1-methoxyhexane is 116. Removal of one non-bonding electron gives molecular ion with M by Z value of 116. Beta cleavage like this eliminates pentyl radical and O-methyl formaldehyde oxonium ion with M by Z 45. The molecular ion has delta hydrogen. Abstraction of delta hydrogen gives another radical cation which removes methanol to produce radical carbocation with M by Z 84. It can eliminate ethylene molecule to produce 1-butene radical cation with M by Z 56. The same radical cation can eliminate ethyl radical to produce cyclobutyl carbocation with M by Z 55. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.